The open loop transfer function of a unity feedback system is G of S equal to 5 divided by S multiplied by S plus 1, S square plus 2S plus 5. This is given. This is given. Using Bode plot, this exact plot we will see later. By using Bode plot, find gain margin, phase crossover frequency, gain crossover frequency. All these we have to find. How should the gain be adjusted so that the gain margin becomes 10 dB? We have to adjust K so that the new gain margin becomes 10. Another, how should the gain be adjusted? We have to adjust K so that the gain crossover frequency is 1.2 radians per second. Gain be adjusted, how the gain should be adjusted in the system so that phase margin is 45 degrees. How to adjust K? So we have to find the 3 Ks. One is for the given gain margin of 10. Another one is for given gain crossover frequency of 1.2 radians per second. Another one, we have to adjust the gain so that phase margin is 45 degrees. That and all we'll see after drawing that Bode plot. To draw that Bode plot, the first step is convert the given. Step one is convert the given transfer function into time constant form. Time constant form. Therefore, here this is in omega n square, s square plus 2s plus 5 is given. So it should be 1. Therefore, we can write 1 by 0.2 s square plus here 2 by 5 0.4 s plus 1. We are taking that 5 outside. So if you write the given transfer function in time constant form, what you will get is 5 divided by 5 multiplied by s plus 1, 0.2 s square plus 0.4 s plus 1. Here 5 getting cancelled. Now it is in time constant form. So what is G of j omega? Step 2. Step 2 is G of j omega equal to 1 upon frequency transfer function. J omega plus 1 minus 0.2 omega square plus 0.4 j omega plus 1. This is the frequency transfer function. Here, omega 1 equal to 1 by 1 equal to 1. Omega 2 equal to 1 by, this is t square, square root of 0.2. 1 by root 2 equal to 2.3. Second corner frequency is 2.3. So now we have to form the table. Table is serial number. First factor 1 by j omega. Factor. Second factor is 1 by j omega plus 1. And the third one is 1 by minus 0.2 omega square plus 0.4 j omega plus 1. So corner frequencies are no corner frequency for this factor. Here corner frequency is 1. Here the corner frequency is 2.3. 2.3. Now slope contributed by each factor. Here minus 20, minus 20, minus 40 because second order. So net slope contributed by each factor is minus 20, minus 40, minus 80. Now we have to write the coordinates. If you know the coordinates, we can draw the Bode plot. The coordinates are, what is the lowest corner frequency? 1. Therefore, we have to start with 0.1. 0.1. Here 1. Here 2.3. Then 23. 2.3 and 23. and 23. So these are the coordinates that we have to find. The first coordinate is what? This coordinate y equal to 1 by 20 log 1 by omega. That is equal to 20 log 1 by 0.1. That is equal to 20 log 10. That is equal to 20 dB. Therefore, the coordinate here is 20. The coordinate here is 20. The next one is, now this becomes omega 1. This is omega 1, y1, omega 2, y2. Therefore, y2 equal to 20, sorry, what is that? Here we have to use this slope, minus 20 log omega 2, that is 1 by 0.1 plus 20. That is equal to, this is 1 by 0.1 is 10, log 10 equal to 1. Therefore, minus 20 plus 20 equal to 0. Therefore, the coordinate here is 0. The next coordinate. Then this becomes omega 1 and this becomes omega 2. This becomes omega 1 and this becomes y1. This is y1. This is omega 2 and y2. Therefore, y2 equal to, what is the previous slope? We have to use the previous slope. Minus 40 log 2.3 divided by 1 plus 0. That is equal to minus 40 log 2.3. That is equal to minus 40 log 2.3 equal to minus 14.5. Minus 14.5. Therefore, the coordinate here is minus 14.5. So after 10 decades, the slope is decreases at the rate of minus 80 dB. Here, here 20, 40, it decreases at the rate of minus 80. Therefore, 80 minus 14 is minus 94.5. The coordinates are minus 94, the 23, 94.5. Now we can draw the Bode plot. Before that, we have to find the phase angle. phase angle. For that, we have to write the expression for angle of G of J omega. Expression for angle of G of J omega. What is the angle of G of J omega equal to, the first is J omega in the denominator, so minus 90 degree, minus, because no real part. Then minus tan inverse of, for second term, for this tan inverse of omega minus tan inverse of, what is the imaginary part? 0.4 J omega. Tan inverse of 0.4 omega divided by 1 minus 0.2 omega square, real part. Imaginary part divided by 0.4 omega divided by 1 minus 0.2 omega square minus 180 degree, as omega tends to infinity. This is minus 90. This is minus 90. Therefore, when omega equal to infinity, it is 360. When omega equal to 0, minus 90. Therefore, angle varies from minus 90 to 360 degree. That's all. So we have to form the table and to find the angles. Omega, angle of G of J omega. First, 0.1, 1. Then corner frequency is 2.3 and 23. That's all. So when you substitute 0.1, the frequency, if you substitute 0.1, you got minus 98 degree. For 1, you are getting 162, minus 162 degree. 2.3, you are getting minus 229. For 23, you are getting minus 351. Minus 351. For infinity, you will get 360 degree. Minus 360 or plus 360. Minus 360 degree. For that, you can draw both magnitude plot and phase plot. Yes, this is the magnitude plot for the given data. Yeah, for the table data. This is the phase plot. This is the phase plot for given for table data. Now we have to find the gain margin and phase margin. We have to draw a horizontal line at 180 degree. At 180 degree, draw a horizontal line. It cuts at A, and draw a vertical line at A. This is what? Omega PC. This is 1. This is 2, 3, 4. Omega equal to 4 radians. Second is phase crossover frequency. Draw a vertical line. It cuts at B, the phase plot. The magnitude is minus 0.5 at B. Therefore, gain margin equal to minus of minus 5.5. That is equal to 5.5 dB. 5.5 dB gain margin. What is the phase margin? Phase margin equal to 180 plus phase angle 5. That is equal to, how to find that? Draw a horizontal line at 0 dB. It's cut at C. C is the frequency at C is called omega GC, gain crossover frequency. Draw a vertical line. You will get an angle. It cuts the phase plot at D. Draw a horizontal line at D. It gives minus 150. Therefore, 180 minus 150, that is equal to 30 degree. Both are positive. Therefore, stable system. First part is over. What is the first question? Using Bode plot, find gain margin, phase margin, gain crossover frequency and phase crossover frequency. The phase crossover frequency is here. The phase crossover frequency equal to 1.3 radians per second. Then gain crossover frequency also asked. Gain crossover frequency is point C. Point C is it cuts the here the frequency is 0.8. Therefore, gain crossover frequency is 0.8 radians per second. So all 4 answers we got for the first question. Now, what is the second question? Using Bode, how should the gain be adjusted so that the gain margin becomes 10 dB? So that the gain margin becomes 10 dB. What is the present gain margin? 5.5. What is the required gain margin? 10. But gain margin has to be increased. Now present is 5.5. If you subtract 5.5, 4.5 has to be, gain margin has to be increased. If you want to increase the gain margin, means we have to decrease the gain. Therefore, minus 4.5 is required. Minus 4.5 is 20 log k equal to minus 4.5. So from that you can find k. So the present required gain margin is 10. What is the present gain margin? Present gain margin is 5.5. Therefore, minus 4.5 is required. Gain required is minus 4.5. Therefore, 20 log k equal to minus 4.5. New gain is minus 4.5. 20 log k equal to minus 4.5. Therefore, this implies log k equal to minus 4.5 divided by 20. Therefore, k equal to 10 power minus 4.5 divided by 20. That is equal to 0.596. Question is, how should the gain be adjusted so that the gain crossover frequency is 1.2? What is omega at omega equal to 1.2 radians? What is the gain at that point that we have to see from the plot? At 1.2, what is the gain? At 1.2, this is 1.2. At 1.2, 5. This is the gain at 1.2. 1.2, what is the gain? This is 1.2 point. 1.2, the gain is 5. Gain is 5. Below 0, that's why minus 5. So, the question is, the new gain crossover frequency must be 1.2. At 1.2, it should be 0 dB. At 1.2, it should be 0 dB for the new system. But here, the present case, we are having minus 5 dB. That minus 5 dB must be made 0. So minus 5 dB must be made 0 means we need 5 dB gain to make it 0 dB. So 20 log k equal to 5 dB. Therefore, this implies log k equal to 5 by 20 or k equal to 10 power 5 by 20. That is equal to 1.78, 1.778. The required phase margin is 45. The next question is, how should the gain be adjusted in the system so that phase margin is 45? The required phase margin equal to 45 degree. What is the present phase margin? Only 30. We need 45. 45 means what is the 5? This 30, how you got? 180 minus 150 equal to 30. This 150 is 5. Therefore, this 5 equal to 45 minus 180. That is equal to 135. 135 degree minus 135 degree. phi equal to minus 135. How we got this? We know that phase margin equal to 180 plus phi. Therefore, phi equal to phase margin minus 180. Phase margin, given phase margin is 45 degree. So minus 180. Therefore, you are getting 135. At 135, what is the gain? We have to see. At 135, this is 135. This is 135. This is 135. At 135, what is the gain? If you see, it is at 135, it is 4 dB. At 135, it is 4 dB. At 135, 4 dB. This 4 dB must be 0. This 4 dB must be 0. So 20 log K equal to minus 4 dB, because 4 dB is there. You see that plus 4 dB. So it should be 0. Therefore, 20 log K equal to minus 4. So we have to give a minus 4 dB. Then only it will become 0. So 20 log K equal to minus 4. Therefore, log K equal to minus 4 divided by 20, or K equal to 10 power minus 4 by 20. Minus 4 by 20. That is equal to 0.63. Therefore, K equal to 0.63. What is the present phase margin? 30 degree. You have to increase the phase margin. That's why we have to decrease the gain. If you want to increase phase margin or increase gain margin, we have to decrease gain. From that, you can understand that it should be minus 4. But logically, what is the meaning of minus 4? At 135, at angle 135, at angle 135, because that is the required angle. What is the magnitude? The magnitude is 4. The magnitude is 4. 4 must be, we have to make 4 equal to 0. To make 4 equal to 0, the gain required is minus 4 dB. Therefore, minus 4. If you didn't understand the logic, what you can think is, to increase phase margin, we have to decrease the gain. So, minus 4. 20 log K equal to minus 4. Therefore, K equal to 0.63. Today, we have seen how to adjust gain for required gain margin, required phase margin, required gain crossover frequency. In the next class, we will see how to get the transfer function from Bode plot. That we will see in the next class.